interesting MCQ. They say that when 10 cm³ of hydrocarbon is burned in 100 cm³ of excess oxygen, the volume of the residual gas mixture contracted by 20 cm³ after passing through a base such as sodium hydroxide. So we know from the onset, right, that you have 20 cm³ of carbon dioxide gas. Okay, because it's acidic, it will be absorbed by your strong base, sodium hydroxide. Okay, so if this carbon dioxide is 20 cm³ and then you have 10 cm³ of your hydrocarbon, right, the mole ratio of carbon dioxide to the hydrocarbon is 2:1, which means that your CXHY, the X, right, is actually 2. Okay, so this hydrocarbon is C2H Y or X, whatever you want to call it. Okay, so the only unknown here, right, should be working out your H. What is your H? Okay, this second part is very, very important. The remaining volume of gas was just sufficient to completely burn exactly 30 cm³ of the same hydrocarbon. So earlier on, right, we already burned 10 cm³. Now we burn another 30. So in all, right, we used up 100 cm³ to burn a total of 40 cm³ of the hydrocarbon. Okay, so they told us all volume is measured at room temperature and pressure. What is the formula? Okay, so for the CX, right, we already know X is 2. We just need to work out what is Y. Okay, so the part that I highlighted earlier on already told you, right? The 40 cm³ of the hydrocarbon need 100 cm³ of oxygen to burn out completely. So that mole ratio, right, is about 2.5. Alright, from the hydrocarbon to oxygen. You need like 2.5 times the oxygen to completely burn out the hydrocarbon. Okay, so if you were to write out this ratio from your equation, right, this whole part over 1, okay, and then the volume ratio, this is like 25 cm³ used up, and then this was 10 cm³ used up, okay, for the first combustion. Okay, because 30 cm³ will require 75. Okay, because we actually know that the mole ratio hydrocarbon to oxygen is 2.5 times. Okay, so this 25 over 10 is the actual volume ratio. So basically we just need to solve for X, and we find that X is equals to 2, and the formula is actually C2H2. Okay, a very, very interesting question where you needed to combine both the earlier part, the first combustion, and the second combustion to give you an overall picture so that you can get the ratio of hydrocarbon to oxygen. Okay, so do look through this question again. It's a very, very interesting MCQ. I hope you will understand it. If not, just drop in a comment, ask me any questions you want. See you in the next video.